Alrighty, guys. We are now moving to 6.5, where we are applying what we've learned already about systems of equations. So basically, the lesson for today is let's remember what we've done and let's choose the best method to solve something. That's really what this is all about. Okay, so it's kind of like a good review of everything we've done. Really quick, I want to get into a little bit of terminology. A coefficient. So what a coefficient is a number that is directly in front of a variable, multiplying that variable. So if I said something like this, if I said 3x plus 2, the coefficient here of x is the 3, the number that is in front of the variable. Okay, so if I had negative 1/2 x squared plus 2x, we have a coefficient here of negative 1/2 for x squared, and then I have a coefficient of 2 on the x term. Okay, so those are coefficients. Now, here's a review of everything that we've done. So we started by graphing two equations together on the same coordinate plane, and where they crossed, that was a solution to the system, right? Then we used substitution with addition and subtraction. Then we used elimination using addition, elimination using subtraction, and then we modified that equation by multiplying by something other than 1 or negative 1. So like if we had like 2x in one equation and 4x in another, and we wanted to eliminate those, we multiplied, the first equation by 2, and then we added and subtracted. Okay, so those are the methods we've used. Now we're going to look at some examples and determine which method is best. Okay, so what I like to do is I like to identify whether or not, so I'll typically not graph something unless they like specifically ask me for a picture of something, so that method's kind of out. So it's between substitution and elimination. If something is solved for like a variable like y equals 2x plus 3, that's when I like to use a substitution for y, right? But here, in this particular case, there's no variables by themselves. So I like, whenever that's the case and something matches up, I like to use elimination. Okay, so for this case, to get those 7y's to disappear or to eliminate them, we're going to subtract because the signs are the same. So we have 5x minus negative 2x, which is 7x. 7y minus 7y is no y's. 2 minus 9 is negative 7. And then if we divide both sides by 7, we get x is equal to negative 1. Okay, then we take that and we plug it back in for x. 5 times negative 1 plus 7y equals 2. And you could have plugged it into the other equation as well. That's no problem. Should get the same result. Negative 5 plus 7y equals 2. Add 5 to both sides. We get 7y is equal to 7. Therefore, y is equal to 1 when we divide both sides by 7. Okay, so y is equal to 1. X is equal to negative 1. Final answer would be negative 1 comma 1. And they want to know which method was the best in solving this. This would be elimination by subtraction. Okay, so then a 1b, I want you guys to try this one out. Okay, so for 1b, notice nothing is really solved for a variable. There's no variables by themselves. Nothing lines up, but if I multiply the second equation by 2, I can get these terms to match up, right? So I'm going to multiply this by 2. And so I get 6x minus 8y equals negative 20. And then the bottom one stays the same. Okay, since the signs are opposite, I'm going to add. So I get 11x. This goes away. Negative 20 minus 2 is negative 22. Divide both sides by 11, and I get x is equal to negative 2. I'm going to plug that back into the first equation. And so I get 3 times negative 2 minus 4 times y equals negative 10. Negative 4y, let's do this. Negative 6 minus 4y equals negative 10. Add 6 to both sides. I get negative 4y is equal to negative 4. Y is then equal to 1 when I divide both sides by negative 4. Okay, so my solution here is negative 2 comma 1, and I used elimination with multiplication. Okay, again, they want to know that. Okay, 1c, this looks like a perfect example of a substitution. So I'm going to actually solve the first equation for x. So I could do that really easily by adding y to both sides. Okay, so then I get x is equal to y plus 9, and I'm going to take that and I'm going to plug it into the other equation, right? So not for y though, for x, right? So 7 times y plus 9 plus y equals 7. Distribute, you get 7y plus 63 plus y equals 7. Combine like terms, you get 8y plus 63 equals 7. And now I'm going to get y by itself by subtracting 63 from both sides. So I end up with 8y is equal to, if I subtract 63 there, I get 50, let's see, what do I get? 56, negative 56. Divide both sides by 8, and I get y is equal to negative 7. If I plug that back in, x minus negative 7 equals 9. X plus 7 equals 9, x equals 2. Okay, so my answer here would be 2 comma negative 7 for this one, and I did a substitution. Okay. And we have one more, sorry. For example, 1D, this one you can really take your choice. Whenever I have a negative in front of this, some people would solve that for y. I would actually multiply this by 2. So you have a choice here. I'd multiply by 2 though to match these guys up to eliminate, because I kind of prefer elimination. But you could solve for y if you wanted to. This number gets a little bit big, but that's okay. And then 3x plus 2y equals 5. I'm going to add these together. I get 13x equals 39 because these eliminated. So that means that x then is equal to 3. Take that 3 and plug it back in. 5 times 3 minus y equals 17. That's 15 minus y equals 17. Subtract 15 from both sides. I get negative y is equal to 2. Divide both sides by negative 1, I get y is equal to negative 2. Okay, so final answer on this guy would be 3 comma negative 2. And I didn't substitute, although you could have. I actually chose elimination by multiplication. Okay, you could have easily done that with substitution as well. All right, so example 2 says Jared has volunteered 50 hours and plans to volunteer 3 hours in each coming week. Okay, Lucy is a new volunteer who plans to volunteer 5 hours each week. Write and solve a system of equations to find out how long it'll be before they have volunteered the same number of hours. Okay, so for Jared, let's make x equal to weeks. Okay, so for hours, for Jared, we could say y is equal to 3 hours in the coming week. So 3 times the number of weeks, right? 3 hours times the number of weeks plus 50. And then for Lucy, the equation is y equals 5 times the number of hours each week. So I want to know, when do these two things equal each other? Well, I can take my 5x and substitute it in. So when does 5x equal 3x plus 50? Let's subtract 3x from both sides, and we get 2x is equal to 50, x is equal to 25. So therefore, 25 weeks is how I would solve that one. All right, guys, there's really nothing else to teach you. Again, this is kind of a review and just choosing the best method. If you choose a method that the back of the book didn't necessarily choose, that's okay, as long as you can make a case for it being, your preferred method for that particular one. That's fine. All right, guys, we'll catch you guys next.